Welcome to the Dynamic Learning Hub of ExcelR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. ExcelR. We don't just train, we build careers. Welcome to the dynamic learning hub of ExcelR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. A hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Want to get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. ExcelR. We don't just train, we build careers.
Okay, right. Good evening, everyone. Uh, so welcome back to our IoT sessions. I hope you are enjoying these sessions. Uh, so please confirm me if my voice is audible. You can confirm in the chat box. Yeah, okay, right. Thank you, and also please confirm me if my screen is visible for you. Yes, let me. Fine. So please confirm me if my screen is visible. Yes. Thank you. Thank you so much. Thank you. Okay, right. So till now we discussed a few things. Okay, last class we discussed a few sensors, how to integrate that, what is the we discussed, and in today's session also we'll discuss, try to discuss some other sorry, some other sensors and etc. etc. So we discussed a few inputs like temperature sensor, PIR sensor, and also we discussed some output components like LED, buzzer, etc. etc. Right. So again, then today's session, let me discuss one more output device, which is nothing but a servo motor. Okay. So there are few motors are available. Okay, not here, in general. So those are like DC motors are available, servo motors, stepper motors. Okay. So in that we have DC motors are nothing but the shaft will be rotated continuously. Okay. So mostly we use that in some robots, field robots, etc., etc. And we have stepper motors, right? Stepper, the name itself says the motor will rotate in stepwise. Okay. And we have one more motor is available here, which this is called as a servo motor. So the difference here is the servo motor will rotate in some angle. Okay. Right. Say suppose if you see in the toll gates, if you have a what we say bar will be there, right? When in that particular toll gate, so or in the parking sessions, you can see there will be a bar. So whenever any object is there, like car or a vehicle is approached, okay, so the bar will open automatically after detecting some amount of etc. XYZ. So the bar complete that what we say rod will rotate in some angle like 90 degrees or 45 degrees, etc., etc. And after that, it will closes, right? So at that particular type of applications, we use this particular servo motor. Okay. So let us see how this servo motor rotates. So for that, let me take an Arduino board. Let me take an Arduino board. Okay. So this is an Arduino board. Okay, right. So and this servo motor is a digital one, so we can connect it to digital component. Okay. So as you see, there are three pins are there: ground pin, power pin, and signal pin. Am I right? So let me connect it first. So power signal. Let me connect the power pin. So power is connected to some power. Okay, I think, but I connected it to 5 volts, and we need to connect the ground. So ground pin is connected to ground. Okay, and the signal pin, as I told you, this signal pin we need to connect. This is a digital component, so we need to connect it to any one of a digital pin. Anything is fine. So here I connected to what we say a digital component, D4. Okay. So let me write the code. So we need to select the text mode. Okay. So there is an inbuilt code is available. We don't want that. So I'm just deleting it. Fine. So let me write the coding part for this particular servo motor. Okay. So we need to include a library. Okay. So the library is nothing but, so how to include, we know, right? To include a library. So ash include servo.h. So this is the library which we need to include. Okay. And let me define it. So as define like servo pin. Okay. The pin which the servo pin is connected to D4, right? So let me define that. Okay. And then, so here in general, we use like what we say pin mode to connect, right? For here we are not using that particular pin mode. So before that, what we have to do is, so we need to create an object. Okay, as this is a C++, we need to create an object. Okay, so the object is how to create is, we have a class called servo, and in that particular servo we need to create an object. I am creating an object, my name is nothing but my servo. Okay, so this is a mandatory step. So you need to create an object. Using this particular object, we need to run this particular servo motor. Okay, so understood, guys? So here, class and object, C++ have a class and object oriented programming. So servo is nothing but the class, and my servo is nothing but the object. Okay, so coming to the setup, so here we need to declare the pin mode. Okay, so here instead of pin mode, we have one more statement is there. So from that particular object, so I'm using a method called attach. Okay. So in this particular attached to which pin we are attaching this particular servo that is meant by this particular statement. So we already attached that to fourth pin and we declared that using a name called like, right, servo pin. So I am using that. Okay. Got it. So to which pin we are going to attach this particular servo. So this statement will execute. It is nothing but just like our pin mode. Okay. Fine. So after that, I am writing in the loop statement. So I told you this particular servo motor will rotate in what we say in some angles. Am I right? So let me see how to rotate. First of all, let me rotate this servo dot. So to rotate it, we need to use a statement, use a method called write. Okay. So first of all, let me rotate it to 0, first initial stage. I'm giving some delay like 1000, and then my servo dot right. So I'm rotating it to say suppose 45 degrees. Okay, and again I'm giving some delay of 1000. So now rotating it to angle, it is our wish, guys. So I'm just rotating it randomly, like one, like say suppose 90. Okay, delay of 1000. Okay, and okay, right, fine. So let's execute this. Okay, and start the simulation. Okay, so you can see 0, 45, 90. Again, it is going to 0, 45, 90. 0, 45, 90. And this particular servo motor, it is it maximum is 180 degrees. So till 180 degrees, you can rotate this particular servo motor. Okay. So here you can see the motor is rotating like 45 and then 90 and back. Okay. So this is how you can rotate or use a servo motor. You can use it in some applications like opening a door, etc. etc. Got it, guys? Any queries in till here? This is one more component. If you have any queries, you can ask in the chat box. I hope you understood this. Yes or no? Okay, we can also modify if you want to rotate like a gate. Okay, so for that, what we can do is like say, suppose I can use a for loop for int of I equal to 0, I is less than or equal to say, suppose like 90. Okay, so I plus plus. Okay, so simple thing. So I'm using the same loop. So instead of the thing, I am writing like I'm giving some delay. So 1000 will be more for this application. So let me take like say suppose 500. Okay, and rest I'm removing it. Okay, and then start the simulation. You can see now the motor will rotate into that particular 90 degrees slowly. You can see because there is some delay is there, so that's why it is rotating. Okay, let me reduce it. Let's say suppose 100. Now you can see it is just like a gate. It will rotate to that particular angle. Again, it will be comebacks. Okay. So slowly the gate, if you attached any gate or a door, okay, like that, it can be happen. Okay. Got it, guys? Is it clear? Any queries in this? Any queries in this particular program? If you have any queries, you can ask me, guys, or else at least tell me no or something. Yep. Thank you for your response. Right. Right. Thank you. So let us see one more program. Okay, here. So let us attach one more. Say, let's see some smart door of something like that. So what I do is I um use a ultrasonic sensor. Yesterday we discussed, right? So we'll attach an ultrasonic sensor. So ultrasonic sensor, yes. So we use this ultrasonic sensor, right? So in the last session we saw this. Okay, if the distance is what we say, if a distance is low, okay, my servo motor, it's like a what we say, like a smart door, okay, like a toll gate, etc., etc. Fine. So let me connect it. So VCC. So we need to connect to positive. So I connected to the same 5 volts. Okay. And ground pin is there. So let me connect ground to ground. And we have trigger and echo pin, right? So we need to connect a trigger pin to some of any one of the digital pins. So let me connect it to two. Anything is fine. So and we have echo pin. So echo pin is connected to some, say suppose 7. Fine. It is randomly I connected. Okay. So just write the code. I'm writing it. So here let me define one more time. So as define. So trigger pin I assigned it to 2, and hash define echo pin. Sorry, echo pin I connected it to 7th. Okay, right? Sorry, to 7. Okay, so same stuff. And then what we need to do? Oh, we need to um all right, declare that, right? So pin mode of trigger pin I connected it to like a trigger pin is an input, right? So input, and pin mode of echo pin, so output. Okay, I'm using serial monitor, so I'm using this serial dot begin, so of 9600. Okay, fine. So here what we did guys, let me revise you one more time. So we included for this server, our task is like whenever we have a less distance, say suppose on applications like in a smart parking system, or in say in shopping malls, automatic door, okay, whatever. Okay, so in that type of applications we have a ultrasonic sensor. When the distance is less, my servo motor should rotate. That is our task. Okay, so for servo motor we need to include a header file which is nothing but servo.h. Okay, and then I'm defining pins. Okay, so the servo pin is connected to fourth, signal pin is servo motor signal pin is connected to fourth pin. So I defined it servo dot 4, and trigger pin and echo pin. This is for the ultrasonic sensor. Trigger pin is nothing but um, sending a signal, and echo pin is nothing but receive that particular signal, right? So trigger pin is attached to and echo pin is attached to 7. Okay, and we created an object using that's what we say servo class, and my object is nothing but my servo. Okay, and here my servo dot attach servo pin. So to which pin we connected my servo, that is defined by using this particular statement. And I'm using pin mode for both trigger pin and echo pin. And serial begin. So to enable my serial monitor, so we need to use this serial dot begin. So serial, generally we use this particular statement. So to transmit some signal for the serial communications. Okay, serial communication. And 9600 is nothing but the baud rate, as we all know, we discussed in the last sessions. Okay, so 9600 is nothing but the baud rate. Got it, guys? Right, fine. Got it? And then, right. Fine, moderate, and let me delete this particular loop. Fine. So clear. I hope it is clear for you. Yeah. Right. Thanks. So here, let me go and do one more stuff. Is like I'll create an to calculate the distance from this particular what we say from the ultrasonic sensor to calculate distance. I'll use a function. Okay. So let me use a function. Okay. So float distance. So I'm defining this particular distance as a function, and I'm passing some arguments like say suppose int of for trigger pin like t and int of for echo e. Okay. I'm defining this particular function. So inside like say suppose initially I'm taking for distance, so I'm taking a variable called d, and it is nothing but 0. So nothing but the same program which we discussed, but I'm writing it in a different format. So here previously we directly wrote that in the loop. Okay, instead of loop I'm creating an object. Okay. So and also I'm using okay, let me define it. Okay, D and for duration. Okay, I'm taking one more. Anything is fine. Here I took long or int. Anything is fine. So let me take an int. Okay, so duration it is also equal to 0. Okay, and fine. So here I need to make it right. So digital write off. So how to transmit a signal? So T comma. So that is what the trigger pin, right? For trigger pin, we mentioned like T. Okay, let me come back to the loop. Okay, not to get confused, right? So here, I'm taking a variable called distance. Okay, no, distance. Okay, so here I am passing that particular function using trigger pin, comma, echo pin. Okay. So this trigger pin and echo pin from 2 and 7, these two will be passed as an argument to this particular function. This is a function concept. Okay. So here T is nothing but here this trigger pin will be passed in this and echo pin will be passed to E. So trigger first is trigger pin side. So T is initially so I need to pass the whole signal, right? So I'm making it high and I'm giving a after that I'm passing it. I'm making it low. So I'm disconnecting my signal. Okay. And then, so here, so duration is equal to, so as we told yesterday, I'm using a pulse in function. Okay. To receive that particular uh, pulse, right? So pulse E comma high. So using that particular pulse, see, Roddy, echo pin, we are going to receive it. And here D equal to D is nothing but the distance equal to 0.034 into, okay, I hope you know if you attended yesterday's class, we discussed about it by, okay, speed of the sound and the duration. I'm dividing it by 2 because the signal is transmitting couple of times. Okay. So that's it. And then we need to write return D. Okay. So D value will be returned. And then I am closing this particular function. Okay. So here let me write this in the loop. First of all, I'm calculating the distance. Right. So here what I need to do. Can anyone suggest? So first of all, let me print the distance. So serial dot println. So okay, right, print distance. Okay, and series that dist. Okay, and then if right, I'm writing some logic if if the distance is what we'll write, we can write anything, right? If the distance is less than or equal to, say, suppose 30. Okay, so inside that line I'm writing some logic over here. So for int I equal to 0, so I is less than, the same concept which we discussed in the previous program. So here what I need to do, so my servo dot write I, right, giving a delay of, say, suppose 100, and closing all the things. So let me write like here serial dot println, say suppose door after this for loop. So let me write like serial dot println door is closed. Got it? A simple program, nothing much complicated. Um, right. Just for convenience, I'm giving a delay of 1,000. Okay. Understood, guys? Any queries in this particular program? Nothing. Previously, we included that calculating the distance in the same while loop. No, I created a function. That's it. Okay. If you know the basics of this, you can clearly understand for that. Okay. So let me start the simulation. Okay. I hope there are no errors. If there are no errors, then it will be executed. Okay. Initializing. Yeah. So what happened? Start the simulation. Okay. Right. Something is happening. Uh, Still, it is rotating. Why it is rotating? Still, it is rotating. Stop. There is any error? Oh, just check the code, guys. If you find any errors, please let me know. Uh, we can see the distance, right? Distance is 0. That's why it is rotating. Why distance is 0? Hmm. The distance is 0. Pulsing is okay, fine. Okay, let me check it again one more time. Distance, I'm getting a distance as 0. That's why it is rotating. Function D. Delayed is still right, is still right. Okay. Anything will be fine, but I don't know what happened. Still the door is the distance is 0, 0. Can someone find the error over here where I went wrong? Hmm. D4 is connected, 4 to connected. Trigger pin, echo pin is 7, trigger pin is fine. We're getting distance as 0. Okay, fine. Uh, I don't know where is the error. Let me avoid the function. So, trigger pin comma low. So, uh, duration and distance. Echo pin duration and distance, distance. Okay. Still, I'm getting the 0 value. Why? I removed the door opening still by okay, right. Distance is 0, distance is 0. Somewhere why my distance is 0. Okay, let me take float as someone suggested. So I'm just calculating the distance, nothing else. Still 0, 0, 0. Why? The ultrasonic sensor is not working. Just give me a second. Yesterday we did this ultrasonic sensor. Let me go to that. Where it is. Ultrasonic is not there. We're getting it properly. Sorry, guys. So the trigger pin is output and echo pin is input. I wrote it in reverse direction, so that's why I'm not getting it. Now it is done. So a small error in this particular pin mode, guys. So right now it will be fine. So I need to connect power pin. So let me connect it to power. So that so previous I did a mistake like a trigger pin. I made it as an input. So trigger pin is output, right? And echo pin is input. So I made it in reverse, unfortunately. So now you can see. So now the distance is 53. So okay, okay, right. So let me make it below 30. So now you can see the door is opening and the door is opening. Slowly the door is opening. Okay, and if it is there, so nothing. Okay, fine. So again, I need to close it. So I didn't wrote that particular closing program. So here after that, what we need to do is so my servo dot right. So let me make it a 0. Okay. So that's it. Small program. So if it is 0, it is opening, and then it will closes. Below thing, you can see my servo motor is opening, and if it is greater than that, you can see it is closed. Okay, got it, guys? Any queries? So like that, we can do a couple of experiments with this particular things. Got it, guys? Is it clear? Any other queries? Right? You can push in the chat box, or else you can give some reactions also, so that I can understand that you understood this particular program. Fine. Clear, guys? Any queries? Okay, let me move on to some other things. Right, fine. So let us discuss. Let me delete this. Okay, fine. So let topic. So here we discussed the servo motor. So let us discuss one more motor. We have a DC motor is available. Okay. So this is a DC motor. So generally, there are two terminals are there, positive and a negative. So in general, if you give positive to 5 volts and negative to ground, so whenever if you start the simulation, you can see I mean, if you start it, so the motor will rotate. Okay, right. So here, this motor generally, why we are going to discuss this is this particular motors. Whenever you go for any, say suppose wheel robot. Okay, for this type of robots, if you see for any things, so we use some motors. Okay, so these are the motors. So to this particular wheels, we are going to attach a motor. So for all these applications, okay, you can see carefully. So there is a motors will be attached to this particular wheels. Okay, so these are little bit advanced one. So in this also we have a small motors will be there. Okay. So if you go for a general applications, okay, right, fine. There is in this particular applications, you can see, so there is a motor at the back, right? So this is a wheel and this is a motor. Okay. So I'm talking about this particular motor for this some applications. So here, so this particular motor, we can't directly connect to our Arduino. So that is the first thing. Why we can't connect? Okay. Say suppose if we connect this, as this is just like an output, so you can just like an LED or a buzzer, you can give to ground, and you can connect to one and any digital pins. So if in case, so let me write it in a notepad. Just a second. Right. So if you want to rotate this particular motor, okay, so positive, okay, right. So what happens if you give any voltage, so the motor will rotate. So the possible thing is, so if we connect to any digital pin, so here if we connect any uh, digital pin, say suppose like D or D dot, what happens? So the motor, whenever we keep pass like a digital, right, okay, digital write off, say suppose say suppose we connected to 6 like high, what happens? Okay, what happens? My motor will rotate. So whenever we give high, what happens? So 5 volts will be passed through this particular digital pin. Okay, so here let me connect, say suppose 6th pin. Okay, 5 volts will be passed. So the motor will rotate at 5 volts only. Am I right? Okay, yes, that is a possible output. But say suppose this particular motor which we connected, you can see this is a gear motor, this is a DC motor. So these particular motors will have different voltage configurations like 9 volts, 12 volts, 24 volts, etc. etc. But when you directly connect that particular motor to Arduino, you'll get only 5 volts as an output. So the motor will rotate with 5 volts only. So for that, that is one case we can't guide it. If you want to rotate your motor with only 5 volts, then it is fine to connect it directly. Okay. But if you want to use this in in wheeled robots like that, in this particular applications, so here the robot will rotate in forward direction and backward direction. Yes or no? The robot will move in forward and backward. So how in that particular applications, if we connect it directly to this particular motor, we can't rotate our motor in the forward directions or reverse direction. Why? Because we can't give in negative voltage, right? Yes or no? So because one end is directly fixed. Okay. So for that particular purpose, and also if we that motor is rotated in reverse direction, what happens? Reverse back EMF will be generated to the Arduino and reverse current will be generated. So to avoid all these particular things, so we are using a motor driver. Okay. So the motor driver which we generally use is L293D or L293N. So there are two different motor drivers are available. So one is L293D and L293N. So with this particular motor driver, we can rotate our motor in any direction, either in clockwise or in anti-clockwise. Can be done by using this particular motor, and also we can pass enough voltage to the motor. Okay, enough voltage in the sense, right? If you want to pass 9 volts, you can pass. If you want to pass 12 volt to the motor, you can pass, or 24 volts or 36 volts. All these things can be passed, guys, or we can pass that particular voltages with this particular motor driver. So all these things can be done whenever if we connect directly to that Arduino board. Okay, understood. So for that we are using a motor driver. Okay, so let me open the motor. What is this motor driver? So here L293D or L293N. So these are the few two motors are available. So let me see show you the difference. Okay. So this is the difference between both, guys. Let me save this. All right. So here this is a D and this is N. Okay. So why? Okay. Before going to that, let me show you. This is nothing but it is an IC, guys. Okay. Right. Fine. Where are this IC? Yep. Okay. So actually, this is an IC. This is an IC, motor driver IC. So you can see this is an IC. So we need to connect motors in the applications. Okay. But this IC connecting it to a separate board and we need to solder all these things. Yes, we need to connect motor. So further to avoid all these things in the market, we'll get the motor driver circuit board. Okay. So this is the module you'll get in the market. Okay. So you can connect it to your board. So this directly you can connect the inputs and outputs directly without connecting this IC. So this is an IC without soldering all this stuff. We have this particular module. Okay, right, fine. So here these are the modules. Okay, one is D and A. This is the basic differences. Okay, so you can see the current capacity of L293D is like 1.2 amp, but here for the N is you can go up to 36 milliamp. Okay, and here it is up to 4.5 volts to of the voltage range is 4.5 to 5, and here the voltage range is 4.5 to 7. So here you can connect up to drive voltage, nothing but how much voltage you can pass. Okay, like 4.5 volts to 36 volts, but here you can pass up to 46 voltage. So if you have a motor with 46 volts, you can use this particular to the L298N. Okay, this is suitable for small motors and this is suitable for larger motors, and it is for 50% to 90% efficiency and it is 30 to 70% efficiency. So this is how. So let me explain the differences between these two. Also, depending upon the motor, you can choose any one of this particular motor. Okay. So it doesn't mean that you can't connect small motors to N. You can connect. Okay. So in general, for our applications, we use this L293D only. Okay, for smaller applications. Okay. So let me explain this particular IC. What is this IC and how it works? Okay, let me find a good image. Pin out. Hmm, okay, right. Let me choose this. So this is that IC, general IC. Okay. So let me explain this. Okay. So if you carefully observe over here, so guys, are you getting it? What I am saying? Are you getting it? Is it clear? Yeah, fine, fine. Thanks. So this is an IC. Let us work on this particular IC. If you carefully observe, there are inputs are there. Input 1, input 2, input 3 and input 4. Okay. And our outputs are there. Output 1, output 2, output 3 and output 4. And we have VCC2 and VCC1. Two VCC pins are available. VCC are nothing but the power pins. And we have enable pins, enable 1 and enable 2. We have enable 2 enable pins are available and 4 ground pins are available. So totally it is a 16 pin IC, and these are the pin configurations for that. Okay. If you carefully observe, let me go one by one. So here if you carefully observe over here, the left side and the right side both are the same. Am I right? Yes, we have an one enable pin. Here also we have one enable. Two inputs, two outputs, two outputs, two grounds, and one VCC and one VCC. Yes, yes or no? So almost it is a replica for left and right. Both are like a replica. Am I right? So next. So here, let me talk enable pins. So these particular, if you make this particular enable pin, the first pin as high, so what happens is all these pins like input 1, output 1, ground, output 2 and output 3. So from 2 to 7, all these pins will be active high, or that will be enabled. Okay, if you make this particular first pin as high, active high, and all these 2 to 7 pins will be in active. If you make this particular enable pin low, all these pins will be in inactive state. Okay, similarly for enable ninth pin, enable second pin. Okay, if you make this active high, all these 10 to 15 pins will be in active position, or else it will be in disactive position. Okay, so nothing but these enable pins will be acting as an gate. Okay, whenever this gate is high, so all these 2 to 7 pins will be active. Whenever it is low, it all the pins will be in inactive position. Okay, right. And we have two VCCs. So VCC1 and VCC2. So here VCC1 will be acting as a power to the what do we say, motor, and VCC2 is a power supply to the IC. Remember this point. So VCC1 is a power supply to the motor. So if we are connecting any motors to this particular IC, enough voltage that will be supplied to this particular VCC1. So if this VCC2 is a power supply to the what we say, motor, sorry, to the IC. Okay, VCC1 is for the motor and VCC2 is for the IC. And here input one, we need to give pass some inputs, right? So notepad. Okay, so if you want to make it clockwise direction, so we need to give a condition like high, comma, low. Okay, if you want to make rotate in anti-clockwise direction, my condition should be like uh, low, comma, high. Okay. So for then stop, you can give anything, low, low or high, high. Anything is fine. Okay, got it, guys. So for the clockwise, you need to give high and low. For anti-clockwise, low and high. Okay. So here, so if suppose any motor is there. Okay, let me show an image for a better understanding. Right, this is good. Okay, if you carefully observe here, so output 1 and 2. So let me save this. Right. So this is little bit good. Okay. So here the output 1 and output 2 are connected to a motor, and output 3 and output 4 that are connected to one more motor. So this particular IC, we are connecting two more. We can connect to two motors. Okay. And the input pins are we are going to connect to any microcontroller. Any microcontroller. Okay. Got it? And coming back to this, so output pins, we are connecting one motor, and to this particular output pins we are connecting another motor. So input 1 and input 2 is connected to IC, and also 3 and 4 we connect to an IC. Got it? Anything left, ground pins are we are connecting directly to the ground. Got it, guys? Is it clear? Any other queries in this? Okay, if you are clear with this particular IC, I'll going to connect this IC to my Arduino board. Is it clear? You can reply in the chat box. Yes, fine. Thank you. So here, let me take a breadboard. So because we need to connect large things, right? I mean, connections will be more. So I'm connecting a breadboard. Okay. So here we need to take an IC. Okay. So what IC we need to take? L293D. So it is an IC. So this is an IC. So let me place this particular IC in the on the breadboard. I hope you are familiar with these breadboards. Okay, right, fine. So first of all, let me connect only one motor. Okay, later on we'll connect two motors. Okay, so here let me give a power supply. So first of all, let me connect, give it to IC, and then ground pin. So ground is connected to some one vertical stuff. Okay. So guys, if you have any queries while connecting, you can ask me. Okay. Right. So if you see, this is enable pin. So how to make this enable pin active high? There are two methods are there. One is through programming part, or else you can connect to 5 volts directly. Active high means right, what it means. So passing 5 volts. Am I right? So here instead of I'll choose the second method instead of programming part, right? A digital right of enable comma high. So instead of that, what I do is I connect this particular enable pin directly to the 5 volts. So that I can reduce some what we say, coding part. Okay. So let me connect. So this is enable pin. So let me connect that to enable 5 volts. and we have a power pin. So for instance, for now, I'm connecting all the things to 5 volts only. Even the motor voltage is also 5. Okay. So connecting it to 5, and also there is some one more power is there. So let me uh, connect that also to 5 volts. Okay. And we have one more enable pin. So let me connect this enable pin. Okay. So as this is a first only one, right? Okay, right. No issues. Done. So after that, so we need to give ground pins. So, okay. So let me connect ground. Okay, these are one ground, second ground. So let me short this and connect it to ground. Okay. Similarly, there are this side, this and also we have ground pins are available. So let me short the upper and the lower one. Anything is fine. Uh, um, okay, done. So okay, instead of using this, I'm connecting the negative positive also. I'm shorting both so that it is convenient for me. So power is connected to power, and enable pin is connected to enable. Okay. So again, I need to connect so one end to the outputs. So output 3. So let me connect this one end to that particular pin, and negative to the output. This is an output 4. I let me connect over here. Got it, guys? So to the output pins, I connected this particular motor. Fine. And then let me give you the connect the inputs to the Arduino board. So this is input 4. So let me connect it to some, say, suppose second pin, and so input this is input 3. So let me connect it to some 3. Okay, that's it, guys. Okay, so as we are using only one motor, so this and I am using, so remaining are all not neglected over here. So this is the connections for this particular IC. So let me go to the coding part, right? So let me remove all this stuff. Right. So the programming part is simple than the hardware. Okay, very simple things. Right. So first of all, let me connect. So ash define. So I'm defining like IN3 is connected to. So this is IN3. It is connected to third pin, right? So 3, and hash define IN4. It is connected to some second pin. So second. That's it. So we need to initialize using the pin mode. So pin mode IN3, it is an input or output. Can anyone tell me it is input or output? Input or output? So please reply in the chat box. Is it input or output? Input? Think twice, guys. Think twice. Is it input or output? I am writing the code in Arduino. So it is output, guys, not input. Okay. From Arduino, we are passing the command like high or low to the IC. So in from Arduino, it is an output, but for IC, those are inputs. Okay, got it? Similarly, so pin mode IN4 comma this is also out. Got it, guys? And let me write it. So I'm writing in the loop. So digital write off. What is my condition? So if I told you, right, if I want to rotate in clockwise, I need to make high comma low. Am I right? So IN3 should be high, and IN4 should be low. Okay. I'm giving some delay of say suppose 2000, and I want to rotate in anti-clockwise direction in reverse like IN3 comma low, and digital write of I IN4 comma high. So what happens in this first loop? What happens? The motor will rotate in clockwise direction. In the second time, it rotate in anti-clockwise direction. The program is simple. The hardware connection is low. This type of IC is little bit complicated, but if you use that particular module which is available in the market, then it is easy for you. Okay, so start the simulation. You can see over here it is rotating. Reverse means nothing but negative. It is positive. It rotating. If you see like negative RPM, right? Nothing but the motor is rotating in anti-clockwise direction. So it is positive, rotating forward and reverse. Got it? Any queries? So similarly, you can connect one more motor, guys. Okay. So let me connect one more motor. That is also the same thing. So let me DC motor, right? Where is DC? Yep. Okay, I'm rotating it. Okay. So here, come back. So let me take one connection. So that positive is need to connect. Okay, fine. Just a second. So like, sorry. Yeah, positive will be connected to output one. Okay, and the negative of that particular motor need to connect it to output 2. Clear, right? And input 2 and input 1. So let me take IN1 is connected to some other pin. So suppose 8, and I'm taking one more. So this is IN2 connected to some 11. Okay, understood, guys? So okay, so let me write the coding part. So it is also the same again. So next we need to connect it like a hash defined, like let me write in the top. Hash define IN1. So I connected it to 8th pin, and hash define IN2 is connected to some 11th. Okay. Similarly, I need to mention the pin mode. So pin mode of IN1, which is also similar. So output. So pin mode IN2 is also an output. Okay. So, okay, let me change this. So let me, so digital write off IN1 comma high. Okay, digital write off IN2 comma low. So similarly, okay, for the next also digital write off IN3 comma high, like a digital write off IN4 comma low. So no, we need to write in reverse direction, right? Low and high. Okay, same thing. Connections are, if once you connections is done. Okay. So you can see the motor is rotating in forward and reverse direction. You can see this motor is also rotating. So this is how you can connect and for any motor. So yeah, if previously we saw, right, like a robot, okay, wheeled robot. Okay, for all these type of what we say, motors, robots, okay, to rotate this in the forward direction or in the reverse direction, for all these type of robots, you can use the same code and the motor will rotate. Okay. To this, you can also add something like what we say ultrasonic sensor. Okay. If in this particular images you can see, like there are some motor, I mean, ultrasonic sensor is there in the front. Why we have this particular ultrasonic sensor? Say, suppose if any object is different, if suppose if it is moving in the forward, any object is there, like a valve or a chair or a table. What happens? What we need to do? We need to change the direction of that particular motor. So whenever it is detected, legs are, suppose if distance is less than, say, suppose like 10 centimeters. So what we need to do, we need to change the direction of that particular motor. So you need to change it, like you need to rotate to left or right, and then you can change it. Like that, we can check using ultrasonic distance, and we can change. So there will be a rain follower sensor is also there. It will follow that particular lane, or you can also use IR sensor. Okay, whenever any object is detected. So ultrasonic is like distance and IR is like an detection. Okay, so like that you can connect. Okay, anything is there? Okay, sorry, here I'm mistaken, right? So this is IN1 and this is IN2. Sorry guys, pardon me. Yep, you're right. Right, same code, you can execute. Okay. So, and I'm giving you some tasks. If anyone can try this particular ultrasonic with this type of motor, you can try it. Okay. And also you can give in the serial monitor if you give like, say, suppose forward. Okay. If you write forward and send, okay, what we need to do, the robot should move in forward direction. Okay. Or if you, okay, let me write over here. If you give in the forward in the input, then the robot should move in forward direction, and like backward. Okay, or you need to go in backward, or right, you need to rotate your robot in the right, and left, if you see your direction should be left. Okay. And also if ultrasonic sensor is there, so if it detects like a distance is like below 15 centimeters, or say suppose below 50 centimeters, so it need to rotate either in right or left. Okay, like that you can develop a project, guys. Okay, and also you can control this robot. So the same command, say suppose if you are connecting it to your software, then you need to give this particular commands. But all the time your motor robot won't connect it to your what we say laptop, right? At that particular time, we can use a Bluetooth module. So Bluetooth module will be there. So that Bluetooth module we need to connect to this particular TX. Okay, let me explain that as the topic came. So Bluetooth module will be there. Okay. So right, these are the Bluetooth modules which can be available with very low cost rate, nothing much costlier. So pin out a diagram. Okay, let me pin out, very simple guys, nothing complicated. Okay, this is good. Okay, let me keep some that this is fine. So let me save it and open it. So this is a pinout diagram, guys, but it shows sorry. All right, this is a good option for you. All right. So this is a Bluetooth module. So say suppose in your applications, so we want to make it independent from your laptop or from the software. At that particular time, you can use this particular Bluetooth module. So this particular module will have 6 pins. Okay, the first and the last pin can be ignored. And you say VCC and a ground. So nothing but we need to give power supply. So it is connected to 5 volts and a ground. And we have TX and RX, nothing but transmitting and a receiving. So this transmitting pin and the receiving pin you can connect to TX and RX. Okay, like that, right? You need to connect it, and then you can install any Bluetooth app from your mobile phone, and you need to write a code in this particular things. So previously we have seen, right, a serial dot available. In that particular serial dot available, you need to read that particular string. If a forward string was received, okay, in this here, if a forward string is received, then robot will rotate in, move in forward direction. So that like type of things you can develop using this particular robot. Okay, understood, guys. So let me for this applications, you can see in this particular image also carefully there is a Bluetooth module is inserted over here. Okay, like that they are connected. Okay, that's the simple stuff, guys. And it is simple. You can also use an ultrasonic in this particular servo motor. The robot will connect, and you can see human following robot. If the distance is less, object is less, you can so develop all these particular applications. The same concept you can develop. Okay, clear with this? Any queries? Any queries in this particular program or concept? If you have any queries, you can ask, guys. Are you following me? Is it clear? Okay, fine, done. So thanks for the reply. So let us see one more concept. Okay, so why I'm discussing all this is this will be useful in your project point of view. Depends upon your project, of course. But in a project point of view, this all stuff will be useful for you. Okay, so let me take one more thing. So let me delete this. Right, fine. So let me take okay, here what I need to tell first. Okay, so let me tell you about an LCD display. Okay, so this is an LCD display. So you know what is this LCD? Can anyone tell me LCD? Why we use this LCD? LCD. So we also use this particular component LCD in our applications. So to display liquid crystal display, yes, absolutely right. So to display some content, and why we need this particular display. Okay. So in this particular program, if you carefully observe, so this serial monitor is available for us. Am I right? So whatever the content we are displaying, that display we are displaying it in their serial monitor. So this serial monitor is available in our ID, in our software part only. But after dumping the code, okay, whenever you are doing this prototype, okay, say suppose you are doing a project on temperature sensor and you want to know that particular temperature values, and you install that, you develop the project, and all the statements were displayed in this serial monitor. But in a real time, of course, you won't connect that particular project to your laptop all the time. But you want to see that particular values at that particular applications, we can use this particular display, LCD display. Got it, guys? So all the this content, all the values or all the instructions will be displayed in this. Say suppose if you are a smart door is there, you want to enter some password. So whenever the password is right, and the door will be open, right? So to display that particular password, so you need to give some commands in this particular LCD, like enter the password. Okay, so you'll enter that password, and that we need to give some instructions, right? The password is right, open, door is opening, or the password is wrong, please enter the correct password. So to display all that stuff, so we need this particular display system. Okay, so let me explain you what is this particular LCD. Okay, if you carefully observe, this is a 16 pin IC or LCD display. Okay, so in general, you have two different types of LCDs displays are available. So LCD, okay, right. So there are two types of displays. Okay, right. LCD is 16 cross 2 and 20 cross 4. Okay, right. So you can see these are the different display systems are available. Okay. So according to your requirement, you can use any one of the display. Okay. So in generally, this we have a 16 cross 2. So and 20 cross 4. 16 are nothing but 16 columns and 2 rows. 20 cross 4 are nothing but 20 columns and 4 rows. Okay. So and here there are some other displays are there. According to that particular display, you can use for your applications. So this is a 16 cross 4, sorry, 16 cross 2 display system. So nothing but 16 rows and 2 columns. Okay. So let me show you. Right here you can see here. So 16 columns are there, and 2 rows are there. Okay, fine. So this is a 16, 2 cross 16 or 16 cross 2, anything is fine. So let me explain this. Okay. So we have a ground pin, VCC pin, and V out. Okay, RS, RWE, DB naught. So totally DB naught, DB1 up to 7, LED, LED, plus and minus. Okay, let me explain the pins. Okay, so DB naught to DB7 are nothing but data pins to pass some data to this particular LCD. Using this DB naught to DB7, we are passing it. And LED anode and LED cathode. These both pins are used for this particular display power. So to in this particular LCD, we have a IC is also available to process that particular data. So for that particular IC, we need to give power supply using this VCC and ground. To displays, we need to give some power. So through LED anode and LED cathode, we can give the power supply. So this ground and VCC and LED and LED plus is for the power supply. And DB naught to DB7, this is for the data pins. E is nothing but enable pin. And RW is nothing but read or write. And register select is nothing but there is some registers are there, um, command mode, etc., etc. For that, we need to use this particular register select. And V out is for the contrast. You know, right? Contrast is nothing but this is a display system to get, even though in our TVs we used to increase or decrease that contrast. Am I right? To get a clear image on that. So for that, we use this particular contrast image. Okay, got it? We use to contrast. So here again, this particular connection of this particular LCD is little complicated. Okay, so let me have a predefined thing is also available. So let me go for that. For that, you need to go for status or select all and just type LCD. Okay, so here at the bottom you can see starters are there, right? So you can see two type of starter kits are there. Let me explain the both. So this is one two wire things. So these are the connections for that particular. So these connections are little complicated. Okay, so uh, right, so this is little bit complicated. For the contrast, here I used a potentiometer. So potentiometer is nothing but whenever to adjust the contrast, we use this particular thing. And so here, let me explain the connections over here. So read and write is connected to ground. So read is nothing but, so here we are writing the data. So from Arduino, we are passing some data to this LCD. So nothing but we need to make it in write mode. Am I right? So if you want to make it write mode, you need to make it this particular read and write to 0 volts. So that's why I connected it to ground. Okay, and register select and enable pins. So these both are connected to Arduino. Okay, so and here LED plus and LED minus VCC ground both are connected to positive volts. So enable pin is nothing but, I told you, whenever you see enable, so nothing but it is just acting as a ground. Sorry, acting as a gate. Okay, so whenever we make this enable pin active high, all the function or module will be function just like a gate on and off switch. Say suppose enable pin is nothing but just like an switch. If it is active high, nothing but the switch is in on position. If it is active low, that nothing but it is in a switch is in off condition. So just remember that, then it is easy for you. Okay, so this is the connection. Okay, and also there is a whenever you use this starter, there is a predefined code is also available, so you can go through that. Let me explain you one more time. Okay, so here again we need to have include a header file which is nothing but liquidcrystal.h. Okay, and here what I'm displaying it, let me show you the output so that it you can understand what we are doing. So here, hello world statement is printing, and below that, the number is nothing but we are what we say, displaying the seconds from the time it is on. Okay, that numbers will be displayed, nothing but some counting the values. Okay, so that is our output. So let me explain you the code. So for that, I took some seconds, which is 0. And this is the file as well. In the previous servo motor also, we need to, we saw, right, we created an object. So here also we created an object, which is nothing but LCD underscore 1. Okay. And in that, we need to pass some, what we say, pin numbers. Okay, so like we don't have any pin mode over here. Okay, so here in the inside this particular object, we need to pass that particular things. So here this is a syntax. Okay, right? So like LCD crystal, this is what we say, uh class. Okay, so there will be some class. Okay, not available. Okay, okay, class. Okay, and here, which is nothing but inside this particular function, we need to pass to which pin the register select got connected, and enable pin connected, and one more thing I forgot. So here there are two modes are available to pass data to this particular LCD. One is 8-bit mode and then 4-bit mode. 4-bit mode is nothing but only using 4 data pins. 8-bit mode is nothing but using all data pins. Okay, that is the only difference. So what happens if we use all 8 data pins? Okay, so here you can see 2 pins are allocated for register, select, and enable pin, and 4 pins for digital pins. Okay, sorry, 4 pins for D4 to D. If we use all these 8 pins, so 4 digital pins are connected to that. So what happens if we use this LCD and can use 8-bit mode? All the pins got used. Am I right? Right, and we can't connect a more sensors or more actuators, okay, like an servo motor, so the pins are getting wasted. For only one LCD, almost if you see 4-bit, 6 pins are used. If you use 8 bits, what happened, 8 data bits, what happens, plus 4, totally 10 GPIO pins got used for using, and for 8-bit. Okay, right. So for that instance, what we do is we use 4-bit mode to reduce that complexity. We use that 6 pins. Okay. So for that we need to write. So file like D4 is connected to which pin? D3. Okay. So dot D3 and D2, D1 and D out. Okay, this is the syntax for that. Okay, inside that 12, 11, 5, 4, 3, 2, 1 are nothing but to which pins these pins are connected. To GP digital pins, these pins are connected. And in the setup, we need to set which LCD are we using, 16 cross 2 or 20 cross 4. That we need to write over here. And as you know, this is LCD that using a dot print, just like serial dot print. So LCD underscore one dot print. So hello world. And here I am moving that particular cursor to the second what we say row. So how to push? So set cursor 0 is nothing but 0th column and 1 row. Okay, by default the cursor will be at 0 cross 0 comma 0, nothing but 0th column and 0th row. Now I am shifting that cursor to the second row, so nothing but 0th column and first row, and I am displaying that particular seconds. After that, seconds are incremented. So that is what the programming is. Okay, if you write, you can see hello world and one. So there are some other commands are also available. You can blink this particular what we say display. Like there is an option is there like backlight. Okay, whenever you use that backlight and enable it, so this particular display will blink. Okay, that are a few other options are available. Okay, so here I told you one concept like uh, for the 4-bit mode, we are using 6 pins of digital pins. So you may have it out. Sir, 6 digital pins is also more for me. So what you need to do? At that particular type of point of view, what we need to do is, let me give 1 second. Okay, there is one more starter is there, nothing but this is that particular things. Okay, so here we are using a module which is nothing but I square C module. Okay, so I'll show you that. Right. So it is available over here. So this is an I square C module. Okay. So this module we need to attach to the back of this particular LCD. Okay, you can see. So this particular IC is available. So this particular module is available, which is nothing but I square C module. Okay. So this particular module need to connect to this particular back of this particular IC. Then with this, we can use only 2 pins. Okay, so if you carefully observe over here, here we are using 8 pins, 8 data pins, 8 data pins. So you can see all these data pins are used, which is loss for us. Okay, we can't connect any other semi-sensor or actuator. To avoid that, what we did, so we go for an 4-bit mode. Okay, so 4-bit mode like this. Okay, 4-bit mode. Even though you say that, sir, it is pins are wasting. Okay, for that, what we need to do, you need to go for this particular I square C module. Okay, so with this particular I2C module, what you have to do, you can use only two pins. Okay, one is SDA and two pins are there. These two pins are we can connect. Okay, so here let me explain you about this I2C. Whenever you use this particular I2C, so SCL and SDA two pins we need to use. SDA are nothing but serial data. SCL is nothing but serial clock. Using SDA, we can transfer the data. Using SCL, we are going to generate the clock. Okay, two things. Using SCL, so we are going to generate the clock, and SDA is nothing but we are sending the data. So there are some options are available. So here, these are connected to this particular pins. So two pins are available. One is SDA and SCL. So we need to connect this SDA to this pin and SCL to then. That's it. Okay. And all these digital pins are available for us to use for any other applications. Okay. Got it? Very simple. And the coding part is the same as you see in the next. Only the hardware connection is different, and you can see the same stuff. Okay. For this particular I2C module we inserted, right? We need to install a library which is nothing but Adafruit underscore LCD. So the same stuff. Begin, hello world, and you can see the same seconds will be hand. Here they use that setup a backlight. So just blinking that particular backlight. Okay, you can see over here. Okay, like you can see backlight is blinking and on and off for every 1 second. So that is the use of that particular backlight. Got it, guys? So this is how you can use an LCD for your applications. Is it clear? Any queries in this? Okay. Any queries, guys? If you have any queries, you can ask me in the chat box. Let me. So if you use a starter, all the code will be available. So if you type in the LCD in the chat box, sorry, search command, you can see this particular starter kits. One is a normal one, how you connect. Okay. And the next one is available like I2C module. So right things. So just copy that and you can use it. Okay. For time being, saying that. Okay. So just give me 1 second. Let me think what to discuss. So you can't, if you want to use multiple LCD, then you need to create in the coding part, if you carefully observe. So here we created an object, right? So if you are using multiple code, you need to create one more object with the same, like LCD underscore 2. And you need to mention that second LCD, where you connected. Okay. So you need to mention that. Okay. If you are using I2C, okay, you can see only, you can connect only one LCD, and you, or else you need to create one more thing, like to which thing you connected. So that will be little bit complicated whenever you use multiple LCD, but there is a possibility is there. You can connect multiple LCD. Okay. So this is the code for that couple of things. Okay. You can use any. Okay, just me give me 1 second, 1 minute, guys. I'll be back. Okay, right then. I hope everything is clear. Anything else want to discuss? Please let me know. Right. I hope everything is clear. So let me check what are there. So gas sensor. Okay, for some applications like what we say, what we any detection of gas. So in suppose like in a driver things, okay, like car monitoring. So the car should not start. Okay, like say suppose like alcohol detection. If the driver is drinking, so using that particular task, I think like we need to detect whether the driver is drunk or not. So there will be a alcohol sensor is available. Alcohol sensor. Okay. So this is an alcohol sensor. Okay. All the gas related stuff, we can use this. Okay. So here this is a sensor. This is available. If you carefully again, there will be a four pins will be there. Um, okay. VCC, ground, D out or D out. Okay. So this is a module. Okay. Generally module. So if your module is not there, it looks like this. There will be a six pins will be available. Okay, using six pins, we need to connect it. But in our market, it is easy for us because we are getting this particular modules directly. Okay, so to detect that particular alcohol, so you need to use this particular sensor and you can detect it. There are analog and digital things are there. So even though in our say suppose police people will use that particular alcohol detection kits are there, right? So in that they'll connect this analog sensor, so whenever analog pin, so they'll depending upon the values, they'll get that particular values. Okay, so and we have a gas sensor is also there. Okay, like this is a gas sensor. Okay, so just like that there are different sensors are there. You can see MQ25 things are there. So one depending upon each thing. Okay. So we use this particular sensor. Okay. Like one for gas, one some for sodium, like that. Some chloroform. So depending upon your applications like air quality. Okay. Like that we have different things. So MQ3 for alcohol. Okay. MQ6 is there. This is for gas. Like that you can see LPG gas detection is there. That's what I'm saying. LPG gas detection is for MQ6. Okay, MQ3 for alcohol. Okay, and there are carbon monoxide is there for MQ9, hydrogen sensor for MQ8. So you can go through this particular things. Okay, so let me MQ series sensors. Okay, right. So this is an MQ series sensor. Okay, you can go through this and according to our applications, you can attach all the stuff. Okay, and a keypad is there. You know, right? Keypad. Um, you can connect that. Okay, keypad. Okay, so first of all, you need to initialize. Okay, initialize this. What are these pins? This is a 4x4 keypad. Okay, so you need to mention what is this 4x4, what are the first pin, second pin using this columns and rows. There are four rows and four columns. You need to write a piece of code for that. So like enter the password. For that you can use this. Okay. So these are the basic components which you can use in your application. We discussed that PIR tilt sensor is there. So using your hand movement, if you want to control a robot or like that, you can use this tilt sensor. Soil moisture sensor. Okay, for agriculture projects, you can use this soil moisture sensor. Okay, and switches are there. Okay. All right, and we have some outputs, RGB light bulb. Okay. So for smaller applications, you can use this Tinkercad to I mean, execute, test your code. Okay, for bigger applications, we'll need to go for hardware part. Okay, so that's it for this particular Tinkercad. You can explore all these particular things on your own. Very easy for task. Okay, and in tomorrow's session, we'll see some other module like Arduino. Okay, we'll see some more other module like ESP32. We'll discuss that ESP32. What is this ESP32 module? Why we are shifting from Arduino to ESP32? That we'll discuss in tomorrow's session. Okay. So if you have any queries until now, you can ask me. So that's the end of this particular Arduino till now. So if you have any queries, let me know. And tomorrow's session we'll discuss. I'll try to introduce a new module. Okay, we are not using any simulator for that. We use a real module, and I'll show you that module and explain you. Okay, and we use our software IDE, Arduino IDE. I'll explain that part stuff. Is it clear, guys? If you have any queries, time is there. Please let me know. So Raspberry Pi, after completing of this ESP32, and we'll shift to that Raspberry Pi. Okay. ESP32 will take some classes because from that particular module we are communicating with the cloud platform, how to transfer the data to cloud, that is there for using that ESP32. That we'll discuss in our next session. So time is there, guys. So if you have any queries, you can ask me. So let me clear you all your queries.
Dear students, I hope everybody marked the attendance. If not, I'm sharing that again. So please mark the attendance and we'll see you tomorrow.
SMD LED, I didn't get you. What is this SMD LED? Right. We already discussed about RGB LED, similar to that. Okay, SMD LED, that will be a series of LED. Just like that, you need to connect just like an LED. How you are connecting LED, in the same way you can connect that particular SMD LEDs. I'm not discussing any particular Raspberry Pi, what is Pico or 5 or 4. I'll just give an overview of that particular Raspberry Pi, how to use that, etc. etc. I'll try to discuss that, but I'm not discussing any particular Raspberry Pi. Okay, just I'll give you an overview of that particular Raspberry Pi. So far, if you want to learn Raspberry Pi, you need to have a good knowledge on Raspberry Pi. Sorry, Python. It will be easy for you to understand. So just go through the basics of Python so that you can easily understand Raspberry Pi, guys. Okay, right. Thank you, guys. Thank you. Meet you tomorrow again, and we'll try to discuss some new module and explore all the other stuff which is related to IoT. Thank you, guys. Thank you. Have a nice day.